what are some limitations of regression? Because certainly, when we make predictions and everything, there's got to be some limitation to what we can predict, right? And of course there is. So here is my note of extreme caution. When using X to predict Y, or it applies to multiple regression as well. If you're using XYZ, well, I guess I shouldn't put XYZ, X or ABC to predict Y. All right. So whether you're using one or more variables to predict Y, you need to limit your prediction. All right. If you go beyond the range of X values that you studied, like in research, then you might run into a problem. All right. So this is written as if you're just using simple regression. So you're just using X to predict Y. When using I am not able to articulate very well right now. When using X to predict Y, where X comes from a range of values not previously studied, that's when you need to exercise extreme caution. All right. You're making predictions beyond the range of data that you have studied. So here is why we need to be careful. Let's pretend that you or somebody else, doesn't have to be you, but there's research on the relationship between X and Y, but only for these values of X. This is what's been studied. Okay. And based on this research, we have identified this relationship. We know that this is, the form that it takes based on the research that we've done. Now, somebody might come along and ask you to do a regression analysis on this data, which you can do, right? And you're going to get the formula for the straight line. And then somebody might come along and say, okay, I want you to predict Y. So you're going to make a prediction, Y prime, but they're going to give you an X value that you've never studied. Nobody has. Now, can you make the prediction? Yes, because you're going to have the formula based on the regression analysis, right? You're going to have the formula for the straight line. SPSS is going to give you the slope and the y-intercept. So you can certainly plug in this X value to get a Y prime, a predicted value of Y. All right. However, there's going to be no way for you to know how accurate that prediction is. Because remember, we haven't studied this. I put these dots up here just to illustrate that, well, who knows what's going to happen, right? Here, we've studied this range of X, okay, and this range of Y, and we know this is what the relationship looks like. But who knows? With these values of X, maybe we're going to see this pattern. Maybe they're going to take a nosedive, like the economy recently, all right? We don't know because we haven't studied it. So if, let's say, we establish a relationship here and we use this to make a prediction, and somebody says, predict Y with this X, well, we're going to predict it to be way up here, right? Why? Because we're basing it on what we saw initially. So our predicted value of Y is going to be up here, which is going to be very far off if, in fact, this is what happens to Y for this range of X. All right? So, again, can you make a prediction for an X you haven't studied? Yes. Will you know how accurate your prediction will be? Absolutely not. No way to tell. Unless we actually do the research, and get the actual XY values for this range of X, we have no idea what will happen to the relationship. All right. And so we also have to be careful because we can establish a relationship between X and Y. And let's say that relationship was studied in the year 2000 and now it's 2020. All right. So is the relationship still hold, right? Is the relationship changed from 2000? Well, it might have. And so if we're basing predictions based on old data, it's entirely possible that those predictions will be far off, right? We just don't know. So we have to update our research every once in a while to continue to make good predictions.